Hello everyone, and welcome to Statistics. What I'm going to do is we're going to walk through this first chapter, going through some of the different sections to include Intro, Section 1.1, 1.2, and 1.3. Different videos for each one, and then there'll be a lesson that corresponds to each one, or a homework assignment that corresponds to each one. What I'd like you to do is listen to the video, watch, take notes, and then do the homework after each section. We're going to start with Section 1.1. Exploring data, an introduction, data analysis, making sense of data. The objectives for this section is by the time we're done, you'll have been able to define individuals versus variables, distinguish between categorical and quantitative variables, understand what a distribution is in general, and describe the idea behind inference. First definition we're going to talk about is statistics. It's the science of data, just in general. Everything that we look at, and it's very popular these days. A lot of companies are relying on statistics. It's becoming more efficient, and it's one way to look at data and break down who should we sell to, what category sells the most, what area sells the most. Every business looks into statistics now more than they did 10 years ago. Then there's data analysis. It's the process of organizing, displaying, summarizing, and asking questions about the data. Some definitions we need to talk about, and that is individuals. Individuals are objects or people, animals, and things described by a set of data. The variable is any characteristics of an individual. For example, I might go through and ask every student their name. You're the individuals. What's the variable? Their gender. That might be something I would look at. However, there are two different types of variables. There's categorical and there's quantitative. Categorical, the key word in categorical is the word category. That is where we're going to break things into categories. Like my favorite color is red, orange, blue, green. Gender would be a category, male and female. Versus quantitative, which more takes on numerical values. However, we do have to be careful with quantitative in the idea, for example, our cell phones. Our cell phones have a cell phone number. Well, that takes on a numerical value. However, that is a categorical variable because cell phones, the number itself is like a name for our specific phone. So not every number is quantitative. Sometimes we call categorical qualitative data, but in this book they really use the word categorical. A variable generally takes on many different values, and it can be anything that we've been talking about in terms of numbers or names, and then it can be broken down into different sections. And then how we go about graphing that is how we analyze the data. Well, before we can go analyze the data, we need to talk about a distribution. How is it distributed? Where is it the most? For example, we might look at a model of a car versus the miles per gallon. Well, when I go to look at this, I'm going to then break it down. You've got the Acura, the Audi, the Bentley, you got all of these different types of cars and their miles per gallon. That's our variable of interest, is our miles per gallon. But when I go to analyze it, I'm going to go ahead and graph it. One of those cars has a 14 miles per gallon. One car has 18. I can tell you right here that 3 cars have 25 miles per gallon. So this helps me go through and distribute and look at the distribution and go, all right, well, we're pretty heavy in the 25 to 33 range. That's where a majority of the cars are. So this 14, I can tell you, well, that's a little low compared to all the others that I'm looking at. And I can tell by looking at the distribution. How are they distributed? How are they spread out? Is another way to kind of think of it. Things we want to do when we explore data and how to explore the data is, number one, we want to start examining each variable by itself. And then we want to look at the relationships among them. We want to start with the graph. When we start to look at the graph first, what happens is then you can start to focus in on some different things. And then once we look at the graph, we can go, all right, well, it looks like it's pretty heavy around here, maybe centered around this area right here. Somewhere in here might be our mean or our median. I'm not quite sure. So then we'll go to our calculator, put the data into our calculator or our computer, and then we'll break it down and look at the actual numerical summaries. And I can now tell you, all right, well, our mean is 27. Our standard deviation is 4.54. Our sample size was 24. A lot of different ways you can do it. But first you're going to start with a graph, look at the data itself to kind of give you some direction, and then we'll look at the numerical values and spread it out from there. When we look at data, we really start with something called the sample. It's kind of like when you go to Sam's Club and you buy a sample, or you walk through the aisles and you get a sample of some particular food. Well, you don't get a full pizza. You get a little sampling of the pizza. And then we'd say, all right, well, that piece was pretty good. I bet the whole population, or in this case, the whole pizza is pretty darn good. So we take our sample, we collect data from that sample, which we hope is a good representation of the generic population. In order to get to that, we will talk about something called a simple random sample. But then we're going to talk about performing data and the analysis. Keeping probability in mind, we look at that scenario. Then we make an inference about the population. An inference means a guess about what the population is like. So you have your sample, we look at the sample, we analyze it, then we make an inference or a guess of what the whole population might be like. So I might take a sample of men and my class and say, you know what, on average, men, you are about 68.5 inches tall in my class. That's my sample. So then I'm going to kind of graph it out, maybe analyze it a little bit more, but then I'm going to come back and say, you know what, I bet the whole population of males on average is about 68.5. And I hope that my sample is a good representation of the whole population. That concludes this section. In this section, just to summarize things that we've learned, a data set contains information on individuals. For each individual, data give values for one or more variables, categorical or quantitative. Sometimes categorical is called qualitative. Then we look at the distribution. How is it mapped out? How is it graphed? What does it look like? Where is there a majority? And then from there, we can look at the actual numerical numbers and take a guess as to what the whole population might be like, and take an inference or take a guess as to what the mean might be or the median might be, just looking at our sample, and we predict to what the whole population is. In section 1.1, the next section or the next video, we will learn about bar graphs, pie charts, two-way tables, and conditional distributions. Thank you for listening, and I hope that helps with intro section for chapter 1.